Okay. So far yes. So far we talked about, we already made a board, we made a schematic, right? We made a schematic and then we create a board, and then now it's time to send it to the manufacturer. Okay. So before sending it, there are some basically concepts that you have to know. Now, the first thing is called ERC test. So what does ERC stands for? It's electrical rule checking. So the first thing you have to know is ERC, electrical rule checking. This one is actually has nothing to do with the manufacturer, because electrical rule, as you know, they are universal. So before sending it, you have to do ERC yourself to make sure that all the electrical rule are basically they are checked and everything is does make does make sense electrically. That means when you go to your, so remember last time we made this. This is a regulator that is custom made, connected to EEPROM. Now, this is a schematic that I made. Now, I want to check it. So what you are going to do here, okay. So what you do, you go to a schematic and you type here ERC and you press enter. So then you see I have ERC errors, and they make sense because it says unconnected input pin. So all of these are not connected to anything, all of these pins, and it gives me error, which I know, right? So you can click on it and say approve to get rid of those errors, and it shows which pins it's talking about. They have to be connected to something, because what I designed here is not a fully functional circuit. It's just for teaching, and you see I'm getting error for my pins that are not connected to anything. So you can say approve and get rid of them. And the next thing that you're looking at is warnings. So warnings are different from errors. Warnings, they're just warning. It says power pin IC IC1, which is this one, ground connected to this pin. So these are just they're not error. They're just basically warnings. Okay. So power connected to VCC is connected to that. Yes, I connected them. Okay. So if you made a mistake and connected something to a different pin, you get warnings. But since I did these connections, I'm okay with them. Okay. So that's it for the schematic. Before sending your circuit, again, as a summary, you have to check ERC, which stands for electric rule checking. And it just gives you if any universal rules are not met. Okay. Then you go and do the same thing for the board. Then you go to the board. Now, this is the board I made yesterday. there is the same checking that you do for the board. It has, so ERC, now you know what ERC means. You do the same thing for the board. Now this one is called DRC. Now the fabrication and the board, unlike your schematic, depends on manufacturer, because you eventually want to send it to a manufacturer, and that's when you have to do design rule checking, or DRC, design rule checking. Okay, so why we should do that? Because different manufacturers have different piece of equipment, they have different rules, and according to those rules, you should follow the rules to see how closely, for example, here, how closely the components can be laid out. So you have to be careful with that. These are all following design rule checking. Okay, so how would you check DRC? You come here and you type DRC, and this will come up. Now, I have here OSH Park design rules, but this is OSH Park design rule, or OSH is a company in US that makes boards. So I'll show you how to upload the DRC for OSH. So here you see that all the layers, clearance, everything is distances, sizes that you shouldn't be concerned about, but there are lots of information. Mass, miscellaneous, file. Okay. But I want to see actually one from Eagle itself. So if I open, for example, this testing, the one I did with you was lab 1 in class assignment. So let's look at this board, for example. Flashing LED. Oh, this one is outside. Okay, so this is another board, for example, because I want to start from beginning. Let me see this one. So if I type DRC, okay, so this is another board, and it's, let's say you put all these components and this is a board. When you type DRC, you will see Eagle design rules. Why the other one? The other one because I went to the end and I chose OSH company to send my board. So this one is from scratch. If you haven't done anything, when you type, when you type DRC here, this will come. Okay, this will come and it's Eagle design rules. So the default design rules have been set to cover a wide range of applications. Your particular design may have different requirements. So it's all about the rules of the manufacturer that you send your stuff to. But Eagle, if you don't upload the design rules of a particular manufacturer, which when you start doing what I'm doing today, you haven't so far, right? So what you see is Eagle design rule. So Eagle by itself, the software, has some rules that are met when it makes the board, which is in line with most of the companies. That's what they say. But if it's also possible for you to download a file, another file. So this is called, as I said, DRC, design rule checking of when you do it. But it's possible for you to upload DRU, which are the design rules from a particular board house. For example, if you go to OSH Park, as I said, if you Google OSH Park, this company, okay, OSH Park or OSH Park, you see, let's get started. Drop and drag your Gerber files. So you learned today basically how to send your files to a manufacturer. Okay, so that's the goal for today. I'm going to send my file to this manufacturer to get the board done. Before doing that, as a summary, so far I did ERC check and DRC. Now I want to tell you how to do DRU, which is for a particular company and not Eagle. Okay, so how can you do that? It's easier maybe to just Google design rules, OSH Park design rules, to see what are the rules. Okay, and this will come. So for any company you want to order your board, you can go and check their design rule file. So here, as you see, you have OSH Park 2-layer and OSH Park 4-layer. These are the layers of your circuit. If I choose this one, let me see, is to have my board sent to OSH Park, and I'm downloading their rules, their design rules, to make sure that my board is in line with the rules. Okay, so you can save this and save link as. Okay, so I already have it here. Let's save it again. You have to make sure to do, let me put it in, for example, desktop, OSH Park 2-layer. I save it on desktop, save, and it will come here, okay? So now it's on my desktop. Now what I'm going to do is going back to Eagle, for example, here, okay. So how did I bring this? I typed DRC on top of my board, okay? So these ones, you can move them in. I'm sure we'll get an error for this because it's not done. But let's move everything. Yes. I want you to understand what I'm doing today. You already know how to do the schematic and how to put everything on a board. But then there's the next step that you send it to a manufacturer. And so far, I talked about how I can check ERC on the schematic, which checks only for electrical rule, and they're universal. That has nothing to do with the manufacturer. So I already did that for this, for example. This is another circuit, which the board is this one. Okay, so, and then I said, if you want to check this board, then you type DRC. This one is important. This depends on the manufacturer. And I already told you, when you type DRC the first time, Eagle design rules will come up. And if you already know which manufacturer you're going to send your design to, then you have to go Google their design rules and download them, which I did. Then you should go back and press on load here. Press on load. And then get that DRU that you already saved, for example, on your desktop here. Now, once you do that, instead of Eagle, you see the company's design rules here, okay? And then it's hidden here. I put this here. I don't know if you see here. Here there is a tab. It's called check. It's hiding. I see. Here, you see check. So if you check, press check, it's going to check for you and see if I have any errors. I have 15 errors. And one of them is that all the wires are air wires. All the wires are air wires. So that's one error. So what I can do is I can come here, type auto. And then, yeah, now they are, as you see, they became red and blue. So now I can again type DRC and then check again. Now I don't have any errors because I took care of the error. I have only one warning about my wires, but warnings are, I mean, they're not errors, so your board will get manufactured, okay? Now, okay, so I typed, so if you want to check the design rules, type DRC here, and again, load whatever company you want, press on load, get the design rules, and press on check. And you saw that I got some errors. For example, if I put one of these parts out of the board, I should get error as well. So let me see, for example, here. And then I say DRC, and then press on check. I get 3 errors again, overlap, because I took it out, right? So it's a very useful tool before doing anything, before sending your stuff. Make sure to do DRC check. Okay. Now, so far, you should know what is ERC, what is DRC, and DRU are the files from the board house. Okay, so that's good. Now you might ask, okay, everything is checked. Let's say everything is checked and I'm going to send this design. How would I send it? Well, first of all, so what do you think? How do you think you can send this stuff to a manufacturer? Okay, no answer. So I go to File, CAM Processor. Why everything is out of window? Okay, so you see CAM Processor. So first, CAM, it stands for, what it does, it allows you to output any combination of layers to a file. So to answer my own question, how would you send a request? What would you send to a board house to get your board? So the answer to that should be, okay, so we send a file with information, right? We send, so you might think, okay, so I'm sending my design, schematic, and my board file to the manufacturer, and that's it, right? So you might think that, which is correct, but there is a problem with that method. The problem is that Eagle is not the only software on earth that you can do board design with. Okay, there are lots of softwares. The concept is the same, but they have different. It's like they're doing the same job with the different languages. And when you send it to the board house wouldn't know. Okay, so what software did you use, and what did you follow? So it gets hectic if you do that. So the solution for that is they thought, okay, so you're saying the files are from different companies. One is from, for example, Altium. One person is sending a file from Eagle, like you guys, and so on. There are lots of software. So what they do, they say, okay, whatever software, Allegro, for example, whatever software you are using, I don't care. At the end, when you are done with your board and you have all these files, like your schematic, you have your board, whatever you do with your own software, translate it to a standard software, so a standard file, and they call it Gerber. So if you do a PCB a lot, you will hear that, oh, I've sent this company my Gerber file, my Gerber file, my Gerber file. That's what Gerber file means, is that it's a standard file that you have to translate the format of your file to the Gerber file before shipping it to the board house or manufacturer to basically make your board. Okay, it's like, the analogy would be, it's a universal language. Like, maybe some people do something in German, some people do the same thing in French, some people do the same thing in Spanish. And if they want everyone to understand it, then they say, okay, universal language is English. So if you want to tell me something, write it in English. Although you did it in another language and it's the same thing, whatever you want to say it in English. So it's the same thing. That would be the analogy. This is the same thing. They say, okay, whatever software you used, I don't care. Before sending it to me, translate it to Gerber file, okay? And then ship it. So this is Gerber file, a universal file. Now Gerber file by itself consists of subfiles. Because they are used to control what they do, they control the laser printing machine at the end, okay, to make an image of all the traces, holes, wires on top of the PCB layout. So when you're sending this file, it has all the information, and it's controlling the laser printing machine at the end for the manufacturer, okay? Or if you have a machine at home, you need the Gerber file. So Gerber file by itself consists of different files, each for a layer of PCB. So as I said, you have a Gerber file that you're sending, right? And then Gerber file, you will see, if I come to Eagle, you see I open CAM processor, and you see here you have Gerber. Output files are Gerber. top copper, bottom copper profile, solder mask top, solder mask bottom, solder mask paste top. So all this information for the laser print. Okay, so why? Because the file you're setting by itself, it has information, and it has by itself, I think, 6 different files. So if the extension is CMP, that means that's for top copper. If the extension is, these are for your general knowledge, you don't have to memorize this. If it is PLC, the extension of the file, it's for top silk screen. Remember last time I talked about top silk and all the letters or numbers you would see on the top layer. So all those informations are in PLC. Another extension, if you see SOL, that's the bottom copper of your board. And PLS is the bottom silk screen. If you have any information in the bottom, you want it to be written by silk screen. So you use this file. All the informations are here. STC.stc, it's the top solder mask. And yeah, that's it. I think I said SOL, PLS, PLC. I think that's it. So as you see, the moral of the story is that Gerber by itself consists of different files. So maybe I'm missing something, but the most important thing for you to understand is that Gerber file is the end file. And by itself, it has several files inside with different extensions. Each contains information about different sides of the board, different layers, and so on. Okay, so that's Gerber file. Oops. Now that's Gerber file. If you go to Eagle, see, you see this. Okay, you see that I have. If you go to, where is it? I had it open here. No. All this information about Gerber file, if you go to File, CAM Processor, you find it. What does CAM Processor is? CAM Processor stands for Computer Aided Manufacturing. And of course, this is Computer Aided Manufacturing because you're sending a file which controls the laser machine, right? So CAM Processor, when you go to File, as I said, and find CAM Processor, you see Gerber files are here. So this is for my design. So you have top copper, bottom copper, you see. Profile is my board, which is very pretty, as you see. Solder top, solder mask top. So everything is here, all the information about different part of my my board. I don't have anything in the bottom for silk screen. On top, I have this. Okay. So as I said, CAM Processor file, CAM Processor, you can find your Gerber file, and it stands for Computer Aided Manufacturing. If I can make this smaller. make it here. Okay. Then when I'm done with this, when you press on process job, it will take everything and convert it to Gerber file. Okay. So first I want you to understand what each word means before just doing it, processing job. So now CAM processor, as I said, stands for computer-aided manufacturing. And it's a software that, as I told you, tells the machine how to make a product by sending its Gerber file. Now, you see another word here, drill. So now you know what Gerber is. What about drill? Another file that you're sending to the manufacturer is called drill file. Drill. This one, the name makes more sense. So drill file, this is, as I said, a secondary file that you will need to send to your manufacturer. And sometimes it's called NC drill file. NC stands for numeric control drill file. And it's used to determine exactly where all of your drill holes are placed on your board and what size they need to be. So remember last time, for example, I put pads on my board. So drill holes will determine if what's the size that your manufacturer actually will accept. Okay, so that's what drill means. That's for holes, drill holes. And for Gerber files, it's just for, again, for your general knowledge, there are two kinds that you might see. The old ones, Gerber files, were RS-274D. The new ones are 227 for X. And 24, the one that they introduced that is newer, 274X, what it does, it uses single file per layer. So for each layer, it uses single file, but as the old ones, it had 2 layers per file, which is just for your general knowledge, okay? So now you have your output files. You have, so this is your CAM processor, right? This is your CAM processor window. Process job. And you can put it, for example, on desktop. It says job process successful. Okay, so now I have a Gerber file. You can come, the thing you can do is export it as a zip file. So press on export as zip. And then it's better to do this. Export it as zip and then press on process job. It's better to send a zip file. So again, I'm going to flashing light on my, okay. Now I'm going to cancel this. Okay. Now, okay, so what do you think the next step? Now I want to send it to the manufacturer. So I'm going to the website of OSH Park, for example, or whatever manufacturer you want to use, and you see, or zipped Gerber file. Send me your zipped Gerber file. So you can browse for files, and I put it on desktop, open. and it's uploading my design. Okay, so this is my board. Okay, so now as you see, it says we detected a 2-layer board of this size. 3 boards will cost $45.70. Okay, so you can upload your board and then put the board name, description, your email, and that's it, which I'm not going to do. And press on continue. And yeah, this company is based here in US, but there are others. I mean, yeah, I think this one is based here, and they're fast. But it's up to you. Any company you want to work with. The only thing you have to know is that you have to send a Gerber file, and now you know what is a Gerber file, right? So that's it, and you get a board on your hands.